So here in this video, we are going to learn about how to repair a dead laptop, new generation dead laptops like Type C laptops, 10 generation onwards with the Type C controller, power delivery. So this is the flow chart, and here are the questions. So these are the questions, and the answer of the question either yes or no. So the first thing is, if the laptop is not powering on, then the first thing we had to use a DC current meter. That small current meter is available. So we have to see how much voltage showing on that current meter. That means first we have to connect adapter to the DC connectors, and then we have to connect that DC current meter to the laptop and turn on the adapter or the DC power supply, and then on that current meter we have to see how much voltage showing there. It's supposed to show a 20 volt, okay, and if it is showing a 20 volt there, then you have to go down. But if you are not showing a 20 volt, showing a 5 volt, then we have to go right. So the question is yes, then we have to go down, and if you know, then we have to go right. So what is the question? The question is whether it is showing a 20 volt on a DC current metered, yes or no. If yes, then we have to go down. If no, then we have to go to right. Suppose the answer is no, that means on the current meter it's showing only 5 volt. That means our V bus voltage stuck on the 5 volt. Then we have to go right again, and the first thing we have to check Type C controller chips. See, each port have their separate Type C controller chips, okay, and it's maybe 3015 or 3017, or it may be different, any chips, and that chips have a dedicated bias, and it's require that chips work on a 5 volt. So first thing we have to check the 5 volt, whether it is coming 5 volt or not, and there is a V bus and there's a CC line. So V bus is a power that is coming from the Type C adapters, and CC line is a communication channel where the Type C controller chip straight away communicate with the adapter. That is called a configuration channel, CC. So that we have to check how much voltage is coming there. If it is stuck at 5 volt, then we have to see the CC line. We have to see all the LDO voltages. See, once the voltage entered into this Type C controller chips, then the Type C controller generate different LDO voltages like 3.3 volt, 1.8 volt, 1.2 volt. It depends. Different voltages are there. That is, and these are the voltage we have to depend on the circuit to circuit. So we have to open a schematic diagram and we have to check LDO voltage. Okay, LDO, that is 1.8 or 3.3. Okay, that we have to check. And if the LDO voltages are not coming, then the Type C controller chip is bad. Okay, so we have to check that. And if all the LDO voltages are there proper, and your bias is also okay, then we have to move the buck boost converter. There is a buck boost converter circuit that responsible to charge the battery also. The buck boost converter means, buck converter means reduce the voltage, and boost converter means they increase the voltage. So there is a circuit is called the buck boost converter, which increase and decrease the voltage. Once the voltage entered into the laptop, is controlled and managed by the Type C controller chips, and once the Type C controller chips receive this voltage, it pass to the buck boost converter, passing the load switches. There are load switches. Load switches mean there are the MOSFET. See, in the older laptop, in the battery charging section, there are two MOSFET number 1 and MOSFET number 2. Similarly, in the Type C laptop, they use a MOSFET that is called the load switch, and once the voltage entered into Type C port, and then this voltage passed from the load switch and entered into the buck boost converter. Now this buck boost converters, you have to check with the help of multimeter whether there is a short circuit or what, with the help of multimeter, and we have to check all the voltage. If there is a if it is everything is okay, but still voltage is not switching from 5 to 20 volt, then the possibility that the buck boost converter chip is bad. Okay, so we have to process like this. The next thing is, now the 20 volt is coming on the DC meter, and the 20 volt is passed from this type C controller chips, which entered into the buck boost to the chips. And then we have to check output from the buck boost converter chips. The buck boost converter, I already told you, the buck boost converter is a bidirectional power delivery. It's called the power delivery. Power goes from in and out also. So there is a buck boost converter chips, and the buck boost converter chip output, it's supposed to be 12 volt, 13 volt, is depend model to model. So and that voltage is called the system voltage, and that system voltage is going to the different buck converters output. Like there are multiple buck converters, like for 3.3, then 5, then 1.8, 1.0, 5, 1.2, and a CPU core and graphics core, this all voltage. And to generate this all the voltages to inputs from all the supplies. So system voltage is somewhere around 12 and 13 volts, depend again model to model. In older laptop, the system voltage is adapter voltage, that is a 19 volt. But in the Type C laptop, the system voltage will be 12 to 13 volts. So we have to check output voltage of the buck boost converter, 12 to 13 volt. And if this voltage is not coming out from the buck boost converter, then we have to go right and you have to check on type C, sorry, on buck boost converter chips. Buck boost converter chips is normally make of ISL or maybe any, but normally use ISL. So we have to check DC in voltage, and DC in is a power to that chip. So there we have to check 20 volt. Then we have to check AC in signal, that is adapter current in signal, that is a 3 volt. So these are the two inputs. The DC in is the power to the chips, and AC in is a signal to the chips. The 3 volt we have to check. And the next signal we have to check is REGN and ACOK. REGN is the output from the buck boost converter chip, that is a 5 volt we have to check. And then we have to check ACOK signal. ACOK is also output signal which generate by the buck boost chips, and 3 volt. So if these voltages are not coming, then the buck boost converter chip is bad. Okay, and if these voltages are coming, but still the system voltage is not generating at the output of the buck boost converter, then we have to see the MOSFET. There are 4 MOSFET, 2 MOSFET in the left side and 2 MOSFET on the right hand side, and in between them there is a coil. Okay, so what happened probably that the MOSFET gets open, so you can straight away replace all the MOSFETs. There are two MOSFETs are there. Normally nowadays they use a single MOSFET. Single MOSFET means actually it is a dual MOSFET, but pack in a single packet, so it's called a dual MOSFET. So you have to see, you have to replace these MOSFET if the system voltage is not generate out to the buck boost converter circuit. And in this way you can solve this output of the buck boost converter chips. Okay, now the next question is if suppose my buck boost converter output is coming, some 13 volt is coming, but the next question is that you have to check straight away, go to the SIO, and you have to check straight away a supply pin, that is a 3 volt, that's called a V standby pin or VCC pin. So there we have to check a 3 volt, if 3 volt is coming or not. So if the 3 volt is coming, then you have to go down, but if the 3 volt is not coming, then we have to go right. Now what will happen if the 3 volt is not coming? So you have to go to the single chip buck converter is there, which generate a linear 3 volt. It is called a VRG3 or LDO3 or 3VL voltage, which developed by the 3.3 volt circuit, that is a linear supply. And if this voltage is not coming, then this 3 volt chip is bad. So you have to check whether is there any short circuit or not. So what you have to do is just remove the adapter from the laptops and take a multimeter, put your multimeter into the buzzer mode, connect one probe to the ground, another probe to the output from the output to the 3VL pin. Their buzzer should not buzzer. Okay, the sound will be not there, so you have to check that. Or the resistance should be high, above 100 ohm. If the resistance is less, like 3 ohm, 5 ohm or 0 ohm, that means there is a short circuit. So if the short circuit is there, then you straight away eject the 3 volt there from the DC power supply, and you have to observe which component is getting hot. Normally in that case, probably some ceramic capacitor gets short or SIO gets short, so like that. So now the next thing is, if my 3 volt is coming to the SIO, then the next thing is, you have to check the NBSW on. NBSW on, or the, or this called the power switch, or this called the power button, and there will be 3 volts. So once we press that power button, it goes to 0, and when we release that button, is come back again to the 3 volt. That means there is a 303 pulse is generated on the power button. It's called the NBS on. Okay, so there will be 3 volt 303 pulse will be generated, and next thing after this pulse generate, the next important signal that we have to check, that is RSM RST 3 volt and PM power button. Here the PM power button stand for the post power button. Post power button means once we press a power button, that is the input power button, is called the NBSW or on, then SIO generate this post power button, this is called the PM power button, which goes to the CPU saying that the user pressed the power button, and another signal generated by the SIO, that is called RSM RST, that is a 3 volt. So you have to check these two signals. Now if these signals are not coming, then you have to go right and you have to check first the EC reset, that is a 3 volt. If it is not coming, then you have to check why this 3 volt is not coming. Then the next signal you have to check AC in signal, that is a 3 volt. Lead switch sensor 3 volt. So these are the input signal you have to check. These are the input criteria to turn on the SIO. If all these 3 volts are coming, like EC reset is coming, AC is coming, lead sensor is 3 volt is coming after that, but still laptop is not turning on, not generating the RSM RST and PM power button, then we have to flash the EC bias. Now the EC bias is there on the SIO, so we have to check the schematic diagram, and we have to check whether my SIO is a programmable or not. If my SIO is a programmable, then in that case we have to flash the SIO. See, there are two bias. One bias is called the EC bias, that the size is 128 KB or 256 KB, and there is a main bias, size will be 8 MB, 12 MB, 16 MB, like that. So that is a differentiate between the bias. So EC bias is basically is responsible to turn on the laptop. So we have to check the EC, we have to flash the EC bias, and then again we have to check pressing the power button whether my laptop is turning on or not. Now if my laptop still not turn on after flashing the BIOS, then in that case the last step is my SIO is banned. Okay, so we have to replace the SIO, we have to put the new SIO and reflash again with the EC BIOS. Okay, so in this way, if the RSM RST is not generate after pressing the power button, then these are the steps you have to follow. You have to check for EC reset, AC in signal, lead sensor switch, that is a 333 volt, and then we have to flash the BIOS, and then if the problem is still not solved, then we have to replace straight away SIO. Now the next question is, suppose now my RSM RST and the PM power button signal is coming, but still laptop is not turning on, then the next important signal that we have to check, that is SLP S3 and SLP S4. Now these two signals generated by the CPU, it's called a PM underscore SLP S3 and PM underscore SLP S4. SLP stand for the sleep mode, that means my power is on now sleep mode, now which is going into the wake up mode, from sleep to wake up. So this is called a SLP-S3 and SLP-S4. Now the SLP-S3 and SLP-S4 both signal, the alternate name will be SUSB and SUSC. So in some motherboard, like especially in the Quanta motherboard, you won't find SLP-S3 and SLP-S4 signal. Instead of that, you will see there, or you will get there, SUSB and SUSC signal. Okay, so you have to check with the help of multimeter. After a power button press, CPU generate this two signal, that is supposed to be a 3 volt both. Okay, so we have to check that. Now if this 3 volt is not coming, If it is remains 0 only, then in that case we have to go right, and first thing we have to check VCC DSW. The VCC DSW is a stand for the power to the CPU. It's called VCC means the supply, DSW means deep sleep wake up. Deep sleep wake up is a is a supply to the CPU to wake up, and this voltage is coming from the 3.3 volt buck converter. See, 3.3 volt buck converter generate two times 3 voltage. One is called a linear voltage, that is a VL voltage, and another is called the always voltage, which is generated by the buck converter. So we have to check that voltage. If that voltage is not coming, then we have to see why this 3 volt is not generating by the buck converter. We have to see the enable signal, we have to see the chip is bad or something like that. Okay, the next thing is, now if my VCC DSW or my buck converter is turned on and it's giving the 3.3 volt and it's going to the CPU, but still laptop is not turning on, then the next important thing is we have to check the RTC section. See, RTC section work with the help of CMOS battery or the main battery, and it's required 3 volts. So we have to check RTC VCC 3 volt, we have to check RTC reset 3 volt, and then we have to see the crystal. There is a 32.7 kilohertz clock crystal is required, so we have to check that 32.7 kilohertz frequency. If this frequency is not generated, then we have to replace the crystal 32.7 crystal, or if the RTC reset is not generated, then we have to see why that RTC reset is not generated. RTC reset and RTC VCC should be 3 volt, and RTC clock will be 32.7 kilohertz. So we have to see all this RTC section. Now next thing is, if the RTC section is okay but still laptop is not turning on, then we have to check DPWR okay. Now the DPWR okay, that means the deep sleep power okay signal, which generate by SIO and given to the CPU. That means this signal wake up the CPU, and that is a 3 volt. So we have to check this 3 volt. If this signal remains 0, then CPU is not going to turn on. Okay, so we have to check that signal. Now if it is not coming, then we have to check why that signal is not coming. But now if that 3 volt is coming but still laptop is not turn on, then in that case we have to heat the motherboard. Now the question is, why we have to heat the motherboard? We have to heat the motherboard because what happen is, sometimes the BGA chips, the balls are so close to each other, so sometimes the moisture is created between the two balls, and there is a electrical connectivity generate between the two ball, and that's create a leakage current between the two pins, sometimes in the SIO also, or sometimes the ball get dry solder. Our CPU is a BGA chips which has more than 1200 legs, that is a pin or the balls. Okay, and sometimes what happens is, by wear and tear, this ball get damaged, or this ball gets dry solder. So we have to heat the motherboard. So you can remove the CMOS battery, remove the RAM, clean the motherboard with the help of ultra cleaner, or you can use Alma to clean the entire motherboard. Now the heating the motherboard, you have the two three options. First, you can use a OTG one. Use a OTG, don't use a microwave on there. Use a OTG one. Put motherboard into the OTG one, but before that you have to remove the CMOS battery as well as RAM or any plastic tapes or what. Then put the motherboard into the oven. Keep the oven temperature is 150 degrees Celsius. Remember, 150 degrees Celsius. Don't increase the temperatures. Okay. The next thing is, put the motherboard for the 15 to 20 minutes. Okay, the 15 to 20 minutes is a fair enough. So, and heat the motherboard like that. Or if you don't have the oven, then you can use a hot gun, and keep your hot gun somewhere around 300 degrees Celsius. Remove that nozzle, increase the full air, and blow the motherboard with the hot gun for 5 to 7 minutes, both side. Or you can heat the motherboard with the help of BGA machine. If you have BGA machine, then you can heat the motherboard or heat the CPU with the help of BGA and recheck again. Okay, now after heating the motherboard, your laptop is turned on, that means the problem is solved. But after the heating the motherboard, problem not solved, then in that case CPU is bad. Okay, in that case the CPU is bad. So you have to replace the CPU. Okay, the next is, now if the SLP S3 and SLP S4 signal is coming but still laptop is not turned on, then the next signal that we have to check SUSP, SCSON and the VR on. These three signals generate by the SIO after receive SLP3 and SLP S4 signal from the CPU. Now this signal, after receiving this two signal SLP S3 and SLP S4 signal, then SIO supposed to generate CSON and SUSP signal 33 volt and we are on also. But if not SIO not generate this 33 volt, then in that case SIO is bad. So you have to replace the SIO. So this is a flowchart for the dead laptop motherboard for the new generation with the Type C controller chips. Okay, so I hope you understand this concept. Simply follow all the steps, simply follow this flow chart, and I'm sure you can able to find problem in the motherboard. So thank you very much.